We have actually two methods to send notification to a waiting thread. One is the notify method we already have seen, and other one is the notify all method. The notify method notifies only one waiting thread for given thread. It is possible that more than one threads are waiting for another thread to complete. So for such a case, we use notify all method. Therefore, we have two methods. First one is the notify method. The notify method notifies only one waiting thread for a given thread. The signature of the notify method is public final native void notify. And second one is notify all method. It notifies all the threads waiting for a given thread. All waiting threads will be notified simultaneously. After getting the notification, all the waiting threads can further execute one by one, because you know that the waiting thread has again to regain the lock to start its execution. That's why all the waiting threads will execute one by one, because all the waiting threads can regain the lock on given object one by one. They cannot get the lock on the given object simultaneously. So let's consider the createThread.java, that is the main thread, is now running the loop. So that loop up to 99,999 is now running by the thread main. And various other threads are waiting for the main thread to complete the for loop. Let's look at the code. This is the createThread.java. In the class createThread, we have the method main. In the method main, we are creating a new object of type shared. Then after, we are creating a new array of type myThread with index 5. So this array will have 5 reference variables that may contain the references of objects of type myThread. Then after, we are calling the parameterized constructor of the class myThread 5 times. And each time when a new object is getting created, that reference will be stored into the reference variable t0, t1, t2, t3 or t4. As a parameter to the constructor of the class myThread, we are passing two arguments. One is the reference variable of type shared and other one is a string. For I is equal to 0, the string will be thread 0. For I is equal to 1, the string will be thread 1, like that. So we are passing two arguments, the reference variable s and the string thread 0, thread 1, thread 2, thread 3 and thread 4. After that, we are starting all those threads. Then after, we are printing main thread is sleeping for 5 seconds and the thread main goes for a long sleep of 5 seconds. After that, within the synchronized block, and here the synchronized block is used with the argument s, means the thread main will get a lock on an object whose reference is stored into the reference variable s. So inside the synchronized block, the method main is printing main thread calling the method add of the class shared 99999 times. After that, the thread main is executing the for loop. So what's happening here? All the new threads have been started and waiting for the thread main to finish this loop. We will come to this part of this code later. First check mythread.java. This is the mythread.java which contains the class mythread which extends the class thread. Inside the class mythread, we have a reference variable s of type shared which contains null. Then after, we have a parameterized constructor which is ready to accept a reference variable of type shared and a string. So that two parameters passed by the method main will be stored into these two variables. After that, with the string s1, we are calling the superclass constructor, means the constructor of the class thread, and we are storing the reference passed by the method main into the instance variable of class myThread. Then after, in the method main, we are calling the current thread method by using the thread class to get the reference of the current thread. Then after, we are getting the name of the thread. And the name of the thread, as we know, will be the thread 0, thread 1, thread 2, etc. After that, all the threads, because this run method will execute 5 times for all the threads. So these threads are waiting for the thread main to complete that for loop. These 5 threads are waiting for a notification from the thread main. But here, see what the thread main is doing. Instead of using here notify all, the thread main is using just notify method. So what will happen here? Only one thread among 5 will be notified and other threads will keep on waiting for the thread main for notification and our output will be hanged. Let's try this code practically. Open mythread.java and this is the same code as we have seen. Open createThread.java and this is the same code as we have seen. Try to compile these three codes once again. It compiles fine. Now run it. Java create thread. All threads are waiting. The thread main goes for a sleep for 5 seconds. The thread main notifies only one thread, only one waiting thread. So notifications are caught by the thread 2. That's why it got over. The thread 2 finishes its execution after getting the notification. But other 4 threads 0, 1, 3 and 4 are waiting for the notification from the thread main. That's why the notify method notifies only single thread, not all the threads waiting for it. Therefore, we need to use the notifyAll method. Stop it, open create thread.java, and instead of using here s.notify, use here s.notifyAll. Now the thread main will notify all the waiting threads. Java C, it compiles fine. Now run it. It runs fine, and all the threads now will be notified. All the threads got notified, and all the threads comes to an end. This time, the main thread will calculate total, and 5 other threads are waiting for total calculation by the thread main. Using notify will notify one of them at random. We do not know which thread will be notified. Thread 0, thread 1, thread 2, thread 3, thread 4. We do not know. Any of one can be notified. And do not notify other 4 threads. Therefore, the output will be a hanged screen. We can use here the wait method with timing that cause all the threads to finish without getting the notification. In the earlier examples, we already have used such wait method. But using notifyAll will notify all threads in waiting. This works even if no argument wait method is used. So here the thread main is calling the notifyAll method. That will notify all the threads in waiting, not just one. There is a famous problem on inter-thread communication, that is producer-consumer problem. The example we just have seen is an example of producer-consumer problem. The thread main is a producer producing total by calling add method this much time, and other 5 threads are consumers that read the calculated value of the thread main. So in the last example, as we have seen, the thread main is the producer and all the 5 other threads were the consumers. The thread main was calculating the final value of I, and other threads were reading the calculated value by the thread main. That's all for this video, guys. Don't forget to like and share this video, subscribe my channel on YouTube, like my page on Facebook, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next video.